I'm Atil Alonso. I'm working as a product engineer for the air conditioning interfaces at the Intesis business unit. And today we are going to configure the air conditioning system for a rental apartment. We will not only configure the control of the air conditioning unit, but also we will include different functionalities like the occupancy or the window contact. Okay, so let's go for it. I will start over, and so I will start by creating my ETS project. Okay, I will keep these settings by default because they are okay for the purpose of this demo. So the first thing will be including the interface in my project. Okay, I will look for it. My AC unit is a Mitsubishi Electric unit, so I will use this interface. And I will choose the Mitsubishi Electric to KNX interface with 4 binary input because I will link the inputs of the device to have the window contact signal and also the occupancy. So I import the device in my project. Okay. So let's have a look to the parameters we have here. Very quickly. Okay, and the general parameters of the interface are parameters regarding, for instance, for the boost recovery. Okay, in my case, I'm not very interested in that part because it's not that common to have the KNX side down while the air conditioning system is still working. I'm not interested in using a NetSync after a boost recovery. Okay. And the next parameter we have here is regarding the air conditioning wired remote controller. And we can simply lock the wired remote controller from here. If we lock here in the parameters, you will need to, if you want to control your AC unit from this wired remote controller, if you have in your project, you will require to reprogram the interface. So for me, it's much better to say here no and enable disable remote controller. We have a similar object here, which is to lock the control objects. Basically, if we say yes here, we will have a different KNX object, which is this one. Yes. And sending one here, this is a binary KNX object. If we send a one here, we will be locking the control of the AC unit from the KNX side. Okay, it's a kind of locking of the AC unit from KNX. Okay, I'm not interested in using it in my project because it will be a very simple control from the end user point of view. So I will not enable it. We have also here the operating hours counters. Okay, basically this object will count the number of hours that the AC unit is on, basically. Here we have a 2 bytes error code. Okay, this might be interesting in the sense that we can link to a group address, even if we are not displaying to the end user. It's not that common in this case to display these kind of errors to the end users, but you can simply link to an address. And if there is any issue, if there is an issue with the air conditioning control, one of the first things to do would be checking this address. Okay, so I will keep enable it. And this is similar to the previous one, but this is a 14 byte character string. So, okay, I will say no because I will use the 2 bytes error code. Okay, let's move forward. Okay, regarding the mode configuration, what we have here is the first thing we have here is to set if the if my AC unit has the fan mode or not. Okay, basically this is a setting you have to set according specifically to your AC unit in your project. In my case, this air conditioning unit has a fan mode, so I will keep it in yes. I'm not interested in using a binary object to change between heating and cooling. Okay, this is an interesting object in case because every KNX thermostat may use different objects to control the climate system, the HVAC unit, for instance. Intesis tries to be compatible with every KNX thermostat in the market. So in case your thermostat is using this type of 1 byte control mode, okay, you can enable and use it. In my case, I'm not going to configure the thermostat itself. I will configure just the interface, but I will create the addresses where you should link the thermostat object. So for me, that object is not important at this moment. Okay, we can enable or disable a 1 bit decrease and increase object. Okay, to change modes with 1 or 2 push buttons. We can set here the polarity of the object, but I'm not interested in this object. Okay. And here we have the binary object for the control and status. We can enable one object of 14 byte character string. Okay, to have the text of every mode. Okay, and we can customize these labels here. And finally, we have here the legacy object for the mode. Okay, basically this is a 1 byte object that we included in our first interfaces, but it's very similar to the standard control mode, which is the 2105 object, this one. Just in case you need it, you can use it here. Okay, it's not important for this demo. Okay, let's keep configuring the interface. Special modes configuration. Here we can distinguish two different functionalities here. One is the power and economy mode, and the other is the additional heating and cooling. Okay, let's start for the first two. Basically, these are two features two functions that we can find in almost every air conditioning unit. Okay, basically, they are similar in the way that you can configure a certain period of time to activate this function. Okay. For instance, if you want to enable the power mode for 30 minutes, you will configure these 30 minutes here, and from the part of the user control, you will have just a binary control, one on-off, binary control, and link it to this power mode here. Okay, so you can trigger this function and wait for 30, it will be activated for 30 minutes. And after that, it will automatically recover the previous status, or you can activate and deactivate as you wish with this binary control. Okay. And we will set here the increase or decrease of the set point temperature. Okay. And finally, we can set here the fan speed for this mode. Normally it's maybe set to 2, 3. That's according to the guest need, to the user needs. And this is very similar, but in the opposite way. Basically, instead of increasing or decreasing the set point, it will relax the set point that the user has set. And the fan speed should be the lowest that the AC unit has. Okay, because this is the economy mode. But the functioning, the object, everything is similar. the power mode. And we have here the additional cooling and additional heating. Okay, it's very common to find the building, to find the apartments where the owner has two different climate systems, normally underfloor heating plus air conditioning, or radiators with air conditioning or fan coils. Okay, so normally when the system is working in heating mode, it's very common to have this the air conditioning system as a supportive, as a secondary system. Okay, in case the demand of the heat demand is very high, basically the KNX system should be able to trigger both systems at the same time, and after a while deactivate the secondary system. In that case would be the air conditioning system. And for this purpose, we have included this function. Basically, there are two ways, again, to manage this type of additional heating and additional cooling. Okay, basically, if you can check in the objects, when we activate this function, we will find one binary control and a status to know if it is activated or not. Okay, and we can set the maximum period of time that this additional heating can operate. Okay, basically we can limit that the operation in time. Okay, not to heat too much or to cool too much during this additional need. We can set a predefined set point for this function and also set here the fan speed. Basically, one way would be controlling this function, limiting this function here, okay? And the other would be, which is also very common, it would be in the thermostat itself, it will automatically send the 1 and the 0 in the binary object, okay? So basically, the thermostat is able to activate and deactivate this function when it's not needed anymore. But anyway, you can combine both functions. You can set the maximum additional heating here, okay? But if the thermostat considers that it's not required, it will simply send a 0 here and deactivate this additional heating. Okay, very simple. In my case, I will just configure again the air conditioning system, so I'm not activating this function. Okay, let's continue. Fan speed configuration here. Well, we have here, the first thing we find here is if our AC unit has different fan speeds or not. Okay, basically for very old or very simple AC units, you may find some in the market that they are not more than 1 fan speed. Okay, but that's not the common case. So in my case, the unit has 3 fan speeds. So I will say yes, and I will leave here the 3 fan speeds. In my case, my AC unit has auto fan speed. So I will set it to yes. And here you can set the DPT for the fan speed control and status objects. Okay, in my case, you can see here how it changes here and here. Okay, basically I will use the scaling. I prefer using scaling values. Okay, here we have again the decrease-increase control for the fan speed. In this case, we have included here additional features like including or not the auto fan speed, and to being able or not to roll over this control. Okay. Normally, if you are going to trigger this function with one push button, the more common is to do it. Okay, because if not, you won't be able to change to come along through all the fan speeds. Okay, we have here a binary object to change between auto and manual fan speed control. We can enable again the binary object for the control and the status. We have the text object, the 14 bytes character string, and a legacy object for the fan speed control. Okay, regarding to the vanes up down. Okay. In my case, my unit has vanes, so I will set it to yes. I have 5 vanes, so for me, it's okay to this configuration. It also has out of vanes up down, so I will set it to yes again. And this the 1 byte object is scaling, so I will keep it like that. Okay, you have to remember that this is according to your KNX thermostat, or that may match with the configuration in your KNX thermostat or your PMS or your centralized controller, etc. And the remaining the rest of parameters we have in this section are very similar to the fan speed configuration, so I will skip repeating this part. Okay, regarding the temperature configuration, we can set here a periodical sending for the status of the set point. No, that's a setting that is normally required for thermostat, because if they don't receive this periodical feedback, they will simply set an alarm or cut anything, perform any action, okay? Because it will be like controlling that the heating system is working properly. In my case, I will set it to 0. I don't want this periodical sending. And we can also set a periodical sending for the return temperature. We can set it cyclically, only on change, or both, okay? Well, I will say the periodical sending, and 3 minutes is okay for me. Again, we have here the binary decrease and increase control for the temperature. We can enable here parameter limits, okay? Basically, these limits are configured in the interface, so you won't be able to exceed them, okay? So be careful at using these limits here. And finally, we have here the possibility to use the KNX thermostat temperature for the air conditioning control. Basically, again, this is a functionality very common or very neat in the case we are sharing we have in the room more than one climate system. For instance, again, the underfloor heating or the radiators plus the air conditioning, because the desired situation would be using only a unique temperature proof to control both systems. So it's very common to have this functionality here. Okay. What happens here is that some units, some manufacturers doesn't allow to override this reference temperature for the air conditioning system. And basically in those cases, what the interface does is to recalculate a real set point for the air conditioning unit according to the reference temperature of the air conditioning unit and this temperature value. Okay, so basically playing with the user set point on the KNX side, the ambient temperature on the KNX system, and the reference temperature of the AC unit, knowing these 3 values, the interface will recalculate the real set point for the air conditioning unit to adapt to the real situation. Okay, this is because the only reason that the Intesis gateway behave this way is that the AC unit doesn't allow to override the reference temperature. Okay, that may be useful or useless depending on your case, because It's useful in the case that you are only controlling the AC unit from the KNX system, and you are not using a wired controller, for instance. But you might be careful when you are using this function. Okay. In my case, I will keep it like this because I want to show you how you can see that over the group addresses. Okay, I will show how to configure properly this functionality here. Okay, we can configure the scenes here. I will skip this part because the scenes configuration is something you find in almost in every kind of thermostat, so I will not stop in this part. Okay. Well, switch off timeouts, that very interesting functionalities that Intesis is included in the interfaces. The first one would be using the window contact. Basically, the purpose of this function is to switch off the air conditioning if the guest or the user opens a window or a door which goes to the outside of the building. Okay. For instance, if you enable this function and there is a terrace or a window in the room, you can locate there a window contact and wire it to the interface so that you can change or you can switch off the air conditioning by using this function. Okay, once the guest or the end user switches off closes the window or the door, it will be able to switch it on again. Okay. Basically, you can define those parameters here. Okay, this is the timeout. Basically, the time between the period of time that which may last between the action, the opening or the opening window action, and the switching off of the air conditioning unit. Okay, sometimes you can allow to open the window for a short period of time, and if the user closes the window during this time, the interface will not switch off the AC unit. Okay, you can set it to 0, you can set it to 5, to 10. That will be according to your requirements. In my case, I will leave it in 10 minutes or 5 is okay as well. Okay. This is the polarity of the object. For me, it's not important because I will perform an internal link. I will show you later. Okay, we can disallow the on-off operation while the timeout is lapsed. Okay, basically, this is a locking. Okay, for the on-off during if the window is open. So I will say no. Okay, I will say no because the main reason is that this is a rental apartment. It's okay to control this function. It's okay to switch off the AC unit automatically if they are, for instance, going to the outside of the room, or they will keep the window open for a long period of time. If they exit, for instance, from the room. But it's not that important to disallow this operation because that may be uncomfortable for the user. So be careful at using these functions here and think also in the guest when you do it. And finally, we can reload the last on-off value once the timeout is stopped. Okay, I will say no. And I think you should keep doing the same almost in very specific situation. Okay. And the next function here is the occupancy function. Basically, it's similar to the previous one. In this case, we can trigger a timeout action. Okay. Basically, this has the same function that the timeout for the window contact. And after that timeout, we will be able to perform one of both actions, or switch off the air conditioning or apply a delta. Basically, relax the set point. Okay. In my case, I say, okay, relax the set point. Why? Because probably the guest will come back after a short period of time, 10, 15 minutes. It's okay. For that time, it's okay to simply relax this, the set point control. But instead of setting to 10 to 20, I will decrease this period of time, because I can enable a secondary timeout, and in this case I will set it, for instance, to 30. Okay, and after the second timeout, it will automatically switch off the air conditioning unit. Okay, basically, if the guests exit the building or the room for more than 10 minutes, it will relax this value, the set point control. And if they are longer outside, they go outside longer than 20, 30 minutes, it will switch off. Okay, that's maybe, you can agree this time with the owner of the building. 20, 30 minutes would be okay. It depends on what they want. Okay. And again, we can disallow the on-off operation while it's not occupied. Okay, we'll set it to no, because I think it's more important to leave this possibility for any reason that they may have there. We can reload the last on-off value when occupied. Okay, I will set it to no. For us, it's not that important. And finally, these are all the settings for the occupancy function. And finally, we found here an additional sleep function that might be set here, but normally the room controller has timers at the same time, so you can configure in both. Here, if you do it in the interface, you will have an additional object here, which is the sleep timeout. And basically, it will switch off the air conditioning after this timer elapses. So, okay, you can configure this function also here. I will not use it. I will only use the first two. And here we can access to the binary input configuration. Okay. I will use two binary inputs. The first one is this one, where I will configure the window contact. So this is a normally closed binary input. Okay, because the normal situation would be window closed. Okay, and here we have it. Let me check it. Here is it. Okay. Okay. We can set a disabling function here. If you want to disable or the window contact, it may be helpful in case the window contact are broken and so on. So you can enable and link it to an address. Okay. Finally, I will, in the function here, I will use, in my case, the window contact, which is an internal link. Okay, so as you can see, there is no object now to link the input. Okay, because the link is internal to the device. And the second will be very similar. In my case, I will set it to normally. Well, it will depend on what type of occupancy control the building has. I will suppose that we will have a normally open control, okay, which means that a 0 will be on no occupied and 1 is occupied, okay, because the normal situation will be not occupied. And again, here I will select the occupancy. That's again an internal link. Okay, so we will have finished the configuration of the interface now, and we should perform the linking. Okay, so it might be very boring to create all the group addresses here and so on, because it's a time consumption task. So I will simply import the group addresses I have created for this tutorial, for this demo. And I will explain anything we will require here. Okay. So basically we will start doing the links as usual. Okay. Which are for instance for the on off, the mode, etc. Okay. Basically those addresses would be the ones you will use with your room controller. Okay, so you can control all these functions directly from the room controller. Okay, this is the set point temperature control. Okay, and this is the ambient temperature. Basically, this is the KNX ambient temperature value. This will be linked, this one, to the control, to the room controller set point control, and this should be linked to the KNX room temperature proof. Okay, normally this proof is located into the thermostat. It's a building temperature proof with a periodical sending, very important. Okay, this is the timeout. Basically, here is called a switch off timeout, but if you remember here, that's our window contact function. Okay, so I will link this to my window contact. That's, if you remember, that's not really necessary. It's not really neat because there is an internal link here. Okay, but it's also important you to know to keep this link down, because let's suppose that you want to force window close. Okay, so you need to link this object to an address. Otherwise, if the input failed, the window contact broke or whatever, you won't be able to virtually, let's say, close the window unless you perform the physical link in the input. So I prefer, I will recommend always to link these functions to an address. Again, the same for the occupancy. We have performed the internal link previously in the parameter section, in the input parameters configuration. But again, we had to link it to an address. And here we can create an address to lock the remote control, okay, in case we need it. Okay, in my case, as I said, it's a simple configuration, so I will simply skip this control. I will not link to an address. Okay, this is for the control, and here we will find the status. Okay, basically, this is the common situation to have different addresses, one for the control and one for the status. Okay, for the feedback to the thermostats. Okay, sometimes it's common to have at the same time the infrared remote controller of the AC unit and with the KNX control. So it's very important to link all these functions, all these addresses with the thermostat. Okay, this is the fan speed, the vanes. This is the AC set point temperature. This is the return. I will show you them later. This is if there is an alarm or not if there is any error in the AC unit. This is the 2 bytes. Okay. Basically, this one will indicate if there is any issue with the air conditioning unit or with the communication with the AC unit and the interface. And this one will show if any air conditioning error. Okay. Basically, those errors should be checked with the AC guy. And, okay, this is the reference temperature. Okay. This is not normally displayed to the user. Okay. But I will link it to an address. even if I'm not using later in the real project, but I can check it, this address at any time. It's the same I have done for the errors, okay? I will not, or you shouldn't, normally it's not required to link it to the room controller or whatever into an apartment unless you have a central controller through the cloud or using any other solution. But it's important that you can keep those objects linked so you can access to them at any time, okay? Probably for a maintenance in the future or whatever. Okay, let me check it. Basically, sorry. Basically, this is the AC set point temperature. And here, the normal situation would be linking to this address here, okay? Because this is the feedback of the set point control. But the situation we face here is the following. It's okay. The normal situation is to control from the thermostat to the interface and to feedback from the interface to the thermostat. Okay, this is something that is done in almost every situation. But in this case, as I said, there is a difference between the set point control. Okay, I will show you through the group addresses. There is a difference between this value that the guest or the user can set through the thermostat, the KNX thermostat, and this value, which is the real value sent to the AC unit. Basically, because of the reason is that we are using an ambient temperature from KNX in this other address, and it will basically the interface, as it's not possible to write this value on the return value that the AC unit is using. Basically, the interface will recalculate the set point according to those three values, which are the KNX set point control, basically what the guest wants, what is measuring in the room, and what the interface is knows, because the interface is able to read the return path temperature of the AC unit. So according to those three temperatures, the interface will calculate the real temperature sent to the AC unit. And this real temperature is the one sent through this object, the status of the set point. So it will be different so far from this one. So in this case, it shouldn't be feedback to the thermostat. Okay? Because let's suppose that I, as a user, I set the air conditioning to 25, but according to what the AC unit is measuring and what the KNX temperature probe is measuring in the room, probably the interface will calculate that the best temperature for the air conditioning is 23. So it won't make sense to display for the customer that the AC unit is in 23, because normally the user doesn't care about the real set point in the AC unit. They are more concerned about the feeling inside the room. So this temperature I have linked for our let's say for our own understanding and to have it available. But in case you want to know at any time the set point, you should use this one. Okay. Okay, and finally, that's all for the moment. Well, I created the additional heating, additional cooling, etc. Others is, but that's very simple because you only have to configure it here in the parameters, and the objects you will have available are binary objects. So simply link the control and the status. These are normally, well, these are controlled from the thermostat, and these are internally, let's say, controlled by the thermostat, but with the logic of the thermostat. Okay, so let's go for it. I will program the interface. I will perform a full download. Okay. I will press the programming button. Let me check it. Okay, now. And it should start now downloading. Simply. Okay. Okay, it finishes the download. So now let's test the control of the unit, and I will use the group monitor here. Okay, into a new window to have it bigger. Logging here, logs here, and okay. I used very simple addresses here, so we can test it faster. Let's have a look. The first thing would be reading. Let me check it. Let's see if there is any report here. Close that. Okay, so basically this is already programmed, so I will start controlling the AC here. I will set it to on. Okay. Okay, I will select. Yeah, it's it. Okay, so I set to on. It says the AC unit is on. I will change, for instance, to cooling. Okay, let me check it. This is the object. Yeah, 21. Yeah. I will change this object here. Yeah, here is it. I will change to cooling, as I said. Okay. And I can see, okay, probably the unit was already in cooling. I will change it to heating. Okay, it says 0. Let me check it. This is the mode status. Okay, this is 20. 150. Okay, now says heat. Cool. I will do the same here. The mode, I will set it, as I say, I will set it to cooling. Just trying because it's changing my DPT every time, but it's okay. Okay, one is the cooling mode now. Okay, this is the ambient reference temperature, which is measuring the AC unit, basically. And I will show you the how the virtual temperature works. So let's have a look to let's set. Okay, the return is measuring 23. Okay, so I will say, okay, as a user I want to set my AC to 21, for instance. Okay, and we have to also provide let's say like this temperature from the KNX thermostat. So okay, I will say if the return is measuring 23, let's suppose that in the thermostat is measuring the, for instance, 22, just to have the different temperatures here. And let's see how it works. Okay, so we have in one part, we have, this is the KNX. Okay, let's say that this is the temperature that the user wants, which is 21. This is the temperature that is in the room, which is 22. And there is 1 degree of difference between the ambient and the set point control, the set point that the user wants. Okay, it's 1 degree. So what the interface does is says, okay, you want 1 degree less than current temperature. So what's the temperature in the return path? It's 23. So I will decrease that degree because the real temperature you want is 22. Okay, because the air conditioning unit will use its own control loop. Okay, so if the guest uses if the interface presses the 21 to the AC unit, it will decrease the temperature by 2 degrees and then stop. But the room temperature here will decrease these 2 degrees at least. So it will decrease till 20, more or less. Yeah? So that's basically how it works. This is why you can see that the user set the AC unit to 21. Okay, this temperature is feedback to the KNX because this logic was still not started until we have sent this ambient temperature here. And then it changed the feedback, okay, because now the real set point in the AC unit is 22. So that's why you shouldn't link this feedback again back to the thermostat if you are using this virtual temperature function. Okay, we can see how it changes if we, for instance, we will change the room temperature now. Okay. Well, this is a periodical report of the AC unit. It says again the temperature is still 23, but now I will suppose the temperature let's suppose that they are coincident. Okay. Both are the same. So now the difference between there is the measure in the KNX and the set point of the user is 2 degrees. And we have these 2 degrees between the return path of the AC unit and the set point, the real set point. Okay, so in that the ideal case, and both temperatures are coincident. Okay, so basically, whenever there is any update in this temperature, the interface will recalculate the appropriate temperature for the AC unit. Okay. Okay, so that's all from my side. I hope you enjoyed this demo. Keep in touch. Bye bye.